Guys, so we are moving on to part 3 of your notes. We have gone through part 1 and part 2. Part 1 was about naming ionic compounds, and those would be specifically binary ionic compounds. Part 2, we started to name polyatomic ions. Now we are going to flip to the other side. So now we're going to look into naming covalent compounds. That is part 3. Okay, so let's get started. As a general review, covalent bonds are going to occur between two or more nonmetals, as opposed to ionic compounds, right? It was a metal and a nonmetal. Metal can't wait to get rid of its electrons. The nonmetal can't wait to pick them up. They're both trying to reach their 8 or their to meet their octet rule so they can both be stable. The good thing about it is that there are no ions that are formed. So because no ions are formed, there is no need to write charges, meaning that you don't need to write any Roman numerals like you have to do with ionic compounds. The one thing I just want to warn you about is that covalently bonded molecules, they may have different whole number combinations of the same element, okay? It'll make more sense once we go through some of these problems, and then I will point out some of them to you. So remember, covalent means nonmetal and nonmetal. We don't form ions, so we don't need to write any Roman numerals or charges. And then you may see some interesting things with the same element, but with different combinations. Okay, so let's go through some rules. In naming covalent compounds, there are 2 general rules that you need to follow, and then I will let you know what the list of prefixes are. So rule number 1 is the first element only gets a prefix if there is more than one atom. The second rule is the second element always gets a prefix and always ends in "ide." Okay, so just like when we were naming organic compounds, they all ended in IDE. It is the same with covalent compounds. The big difference is going to be this use of prefixes. So the first element only gets a prefix if there's more than one atom. The second element always gets a prefix, and the ending is always changed to "ide." Now you're probably like, what are these prefixes? So let's go through them. So prefix, the prefix for 1 is going to be, the prefix for 2 is going to be di. The prefix for 3 is going to be tri. The prefix for 4 should look very familiar when we were doing our Lewis dot structures, right? Tetrahedral. So tetra is 4, penta is 5, hexa is 6, hepta is 7, octa should look very familiar to you. That is 8 when we're talking about the octet rule. 9 is going to be non, and 10 is going to be deca. Okay, so now let's put them into action. So you have some practice problems, so let's go through the list. You should have them on your notes, okay? So the very first practice problem is going to be SO3. All right, so SO3. Now remember the rules. The first element only gets a prefix if there's more than one. Okay, so if you look at sulfur, there's only one, that means no prefix. The second element always gets a prefix, and then you need to figure out what prefix to use. So there are 3 oxygen. The prefix we're going to use is tri, and then make sure that it always ends in "ide." So the answer to SO3 is going to be sulfur trioxide. Okay? So now what I want you to do is I want you to pause the video, and I want you to try and name the rest of them. Okay, I'll give you a minute. Go ahead and do that. Okay, so when we're looking at the next one, which is H2O, okay, so now we have 2 hydrogens in our first element. That means that we need a prefix. The prefix we use for 2 is di. And then if you look at the second one, remember the second one always gets a prefix. There's only 1 oxygen. That means we are going to use the prefix for 1, which is mono. So the answer to that one is dihydrogen monoxide. Okay, let's look at the next one. We have ICl3. So remember, the first element only has 1. It does not require a prefix. The second one has, the chlorine has a 3. It requires a prefix all the time. That's tri. The answer to that is going to be iodine trichloride. Okay, PBr5, once again, Phosphorus does not have more than one, so it does not need a prefix. Bromine has 5 though, so now we need to use the prefix for 5. That would be penta. So the answer is phosphorus pentabromide. Okay, let's take a look at C3H6. Okay, now we have multiple in our first element, so we're going to need a prefix. That is going to be tricarbon. And then we have 6 hydrogen. Now this one is a little tricky, right? It's one of those ones, right? Say tricarbon, hexa, because there's 6, and it would be hydride. The next one is Ci4. First element does not have more than 1, so it does not have a prefix, so that's going to be carbon. I have 4 iodine, so that prefix. And this one is also a little interesting. We don't say iodinide. And then we have N2O3, right? We have more than 1 for our first element. That means it requires us to use a prefix. That would be di, and that's nitrogen. So it's di-nitrogen. I have 3 oxygen. The prefix for 3 is tri. Is PF5. First element does not have more than 1, so there are 5 of them. So I need to use the prefix for 5, which is penta. So it's going to be phosphorus pentafluoride. Okay, then the second to last is CCl. Carbon is only one of them, so I don't need a prefix. So it's carbon, and then I have 4 chlorines. That is tetra again, and it's going to be chloride. So carbon tetrachloride is that answer. Then the last one is CO2. Carbon, once again, is all by its lonesome. There is no prefix needed. That means it is just carbon. Then I have 2 molecules of oxygen, so that is di. And then, of course, oxygen, once again, just like the first one, is oxide. So the answer is carbon dioxide. Okay, so hopefully that was helpful for you guys, and you guys actually got into practice of naming. You guys are going to have some more worksheets where you're going to practice naming, so hopefully it'll get easier. Okay. So now I'm going to give you the name of the actual element, and I want you to write the chemical formula. So I'll do the first one with you. We have disulfur trichloride. Di indicates that you have 2. Sulfur is sulfur, so you have 2 sulfurs. 3 indicates that it is 3, and now we're talking about chlorine. So the answer to that is going to be S2Cl3. Okay, hopefully that makes sense. Same deal, pause the video and see if you can get through the other ones, and then I will walk through them with you. Okay, so the next one, diphosphorus trioxide, that means we have 2 phosphorus and 3 oxide. The oxygen, the answer is P2O3. The next one is carbon deselenide. Okay, carbon is all by its lonesome because there is no prefix. That means that it's just C. Selenide, that is selenium. It says it's di, so that means we have 2 of them. The answer is C, Se2. The next one is carbon tetraiodide. Carbon is once again all by its lonesome, so it's just C. Tetraiodide implies that there are 4 of them, so it should be Ci4. The next one, diarsenic trisulfide. Well, di indicates that we have 2, and we're talking about arsenic here. 3 is indicated by the tri in the sulfide, so the answer would be As2S3. The next one is dinitrogen pentoxide. So we have 2 nitrogens and 5 oxygen. That would be N2O5. The next one, tetraphosphorus decoxide. Okay, yep, this is a big one. So tetra means 4, deca means 10. So we are looking at P4O10. Next one is selenium hexafluoride. So selenium is all by its lonesome, so it's going to be Se. Hexa says we have 6. That means it is going to be 6-fluorine. That is SeF6. The next one, disilicone hexabromide. Di indicates that there are 2 of them, so it's going to be Si is going to be the symbol. Hexa says that we have 6 bromine. That is going to be Si2Br6. And then the last one is diboron monosilicide, right? So di implies that we have 2. We're talking about boron here. The symbol is B. Monosilicide says I have 1 silicone. So the answer is B2Si. Okay. Hopefully you were able to get those correct. And you're going to have plenty of time to practice, right? So hopefully that was helpful. And if you have any questions, you know where to find me.